A decision table testing is a software technique that is used to test the system behavior for different input combination. It is a way of how software testing is which internal structure or program or the code is hidden or nothing is known about it. Unit testing will also be responsible for an application engineer who implements the structure. So basically you are implementing the structure first. You're going to go it phase by phase, understand it unit by unit, and then take it forward. Good morning and welcome to the model question paper solving in software testing B.C.A. 5th semester. This is the second session where we are going to continue with the long type answers and questions. So let's go further. The first one is construct a decision table for a triangle problem. And we're going to see here what is a decision table first. A decision table testing is a software technique that is used to test the system behavior for different input combination. This is a systematic approach where the different input combinations and their corresponding system behavior are going to be captured in a tabular format. That's why you call it as cause and effect factor altogether. So basically, when you're talking about a decision table, you're going to look into the factors called as the cause and effect relationship, and based on this is what you're going to construct the decision table. Let's have a look into it. Now, for example, when you look into a triangle problem here, you will be able to see that first thing is that are we going to form a triangle with the factors of A, B, and C? The first case might be a false and the remaining one are true. Then is A equal to B? Yes, it's true under certain conditions, false under certain conditions. A is equal to C, the first two is true and the remaining are false. Again, you have a true condition. So like this, you're going to draw the entire thing where you're going to find out whether it is a triangle, whether it's going to be a scalene triangle, is it an isosceles, or is it going to be a equilateral, or is it completely impossible for us to even do a triangle here. So what is that we are going to check out here is that whether the decision table is fixing in terms of finding out can we build the triangle or not. Now, moving further, write an algorithm for a commission problem. Now, commission problem is very, very simple. What we are trying to do here is that we are going to talk about on the sales volume of the commissioning. Now, for example, if he is going to get a commission for an X percentage, it is the amount that is accumulated according to the volume of the figure. Now, for example, how is the commission that's going to be calculated? For example, 200 into 5% is the commission. The remaining 1000 minus 200 at 8%, 1200 minus 1000 at 10%. So you would be able to see that you're going to design a program based on the conditions that have been given here, and based on the percentage, we are going to calculate the commission of the salesperson. Differentiate between black box testing and that of white box testing. It is very important. Now, what is a black box testing? It is a way of how software testing is which internal structure or program or the code is hidden or nothing is known about it. Now, in a white box testing, it's the other way around because it's a structural code program that we are going to do in which the tester has the knowledge. This is very, very important. The tester has got sufficient knowledge about the internal structure of the code, and that's a white box testing. Whereas in a black box, the testing is purely done where you do not know anything about it. Now, implementation of code is not needed for a black box at all, whereas in case of a white box, it is mandatory. Now, it is mostly done by software testers. This is mostly done by the developers. That's where the difference is main here. You can see that testers and developers, that means to say that testers will have no knowledge about what is the software all about, whereas the developers would already have the knowledge. Followed by no knowledge of implementation is required. Here the knowledge of implementation is required. It can be referred to outer or the external, but whereas this is an internal one. This is a functional testing that we are going to go through. Here it is going to be a structural testing that we are going to do. Testing can be initiated on the requirement of specifications. The testing is started with a detailed design of the document. So that is the difference that we are going to talk about the black box and the white box testing. Moving further, explain fault taxonomies. Now, there are many kinds of fault taxonomies. Syntactic, which is going to be spoken about here. It is about the syntax, interactions, and conditions that are required to serve, followed by semantical fault. A semantical fault will consist of violation of explicit and implicit assumptions on the component behavior. So, if there are going to be any changes in the behavioral pattern of those particular codes or thing, that's where we are going to bring in the semantical faults altogether. In terms of the non-functional faults, we are also going to understand that, like many subsystems factors here, there are component-based systems also that come inside, which has to satisfy both the functional and non-functional requirements. So what happens here is that the non-functional requirements propagates among the components. So that's where we will look into this non-functional faults altogether. Now, a faulty connector is one which is linked by the connectors, which may include a mismatching protocol. For example, if the protocol is not exactly that is in sync, so automatically that can also lead into a fault taxonomy here. Now, let's try to explain the ER diagram of an SATM, which is also an important question. Now, look here, this is a simple ATM system, and these are the commands that you can see. Moment you walk into a system, you will have to give a pin. The pin is it correct, then automatically it goes into the next screen. Now, you have the terminal screen slots which are being kept here. Now, you can enter into it where you will be able to understand what are all the requirements. So as we log in with the PIN, automatically it will ask you about your details. Then you go into the screens which is going to talk about your savings account, you want to take into a current account, what are the kinds of things that you go inside. So every terminal screen will become a part of the system that needs to be tested. Moving further, we're going to talk about different strategies used in decomposition based testing. Now, this can also be an important question. How does the functional decomposition work? Create a functional hierarchy for a software. Problem is broken into independent task units. Now, this is very, very important. Why? Because what we tend to do is that break the problem into one by one subparts altogether and then start understanding the function and test it. Units can be either run sequentially or in a synchronous call reply manner or simultaneously in form of a processors. During the using planning, analysis and design also comes into picture, which becomes a very, very important task here. So this is going to be a complete functionality where you are going to understand different factors and parameters altogether. Now, followed by the structural strategies of a threat testing that comes into picture. A threat testing that comes into picture is that you would be able to understand that a software is split into threads with each thread running a specific task when all components of the software are integrated for a developer to ensure that the program is run. Now, you need to understand that software is cut into many parts, and when you start integrating each and every part together, you will get a complete software which will run according to the function. Now, for a banking app, the developer must make sure that the app is executing all the transaction as per the client's requirement. This is where the testing comes into action. Now, when we talk about this testing, it also involves integrating the threads through the present level, and it generally starts at the subsystem level and covers the whole system. So you start from the bottom. As you go up, you cover all the parameters together and test it like a complete app. Followed by the next question, ASF. Now, what is an ASF coming? The Advanced Software Framework, which is basically a collection of embedded software for a Amtel Flash microcontrollers altogether. You have a different set. It simplifies the usage of microcontrollers, providing the abstraction of the hardware, middleware, and it's designed for evaluation, prototyping, design, and production phase. So these words I want you to remember. Why? Because this kind of a framework is basically used for an abstraction level, where you see that most of the things are at an abstract or at a higher level. They're being deciphered to the lower level. They're being brought down to the lower level. And finally, the evaluation is done so that you would be able to get the meaning of it. Followed by explain the different levels of object-oriented testing, which is very, very important question. Now, testing an object-oriented system, it's a continuous activity that happens during the software development. In an object-oriented system, it encompasses 3 levels, starting with the unit testing, the subsystem testing, and the system. So let's first start with unit testing, in which what you will tend to do, individual classes are being tested. It is seen whether the class attributes are implemented. That's very, very important. As per the design and the methods, you will not be able to implement a unit on your own will and wish. So you have to go as per the methods and interfaces. Unit testing will also be responsible for an application engineer who implements the structure. So basically, you are implementing the structure first. You're going to go it phase by phase, understand it unit by unit, and then take it forward. Followed by the subsystem testing, which involves a particular module or a subsystem which is responsible for the subsystem lead altogether. It involves testing association of various subsystems as well as interaction of the subsystem well within the outside. It tests and a regression test for each of this is newly released version of the subsystem. So this also comes into picture. System testing is when you put everything together and you would be able to see the responsibility of a quality assurance team coming into picture. They use this regression test, which means they see multiple levels across the system and ensure that the system is correctly in place. Every single aspect has been checked before the new product is released in the market. Now, followed by the GUI, that's a graphic user interface. What's a graphic user interface? It's a software testing type that checks the graphical user interface. The purpose is that to ensure the functionality of the software is as per the specification. Like, for example, the menus, the buttons, the feel, the like of the software altogether. So whenever you're running through an app, you will feel that when you're looking into the screen of the app, you need a button here, you need a check sign, you need to see that the menu is here or the drop down is here. All those functionalities have to be appearing exactly as what the customer wants, how exactly the specification has been dropped upon. So that's why we use this graphical user interface. A user does not see the source code here. What he would see is only the app, and you would see that whether it is working according to the functionalities that has been mentioned. Now, the next one is the issues that are being spoken about in the object-oriented testing. So one kind is that binding of polymorphic component that is required for separate test cases. That's coming into picture. Every server class needs to be interrogated, has to be integrated in terms of the client classes. It is difficult to determine such bindings. It's very complicated. And the integration planning and testing itself is complicated because you need to bind each and everything. You need to combine each and everything. So this becomes quite difficult for us to do a testing like this. Now, explain the classes as a units in object-oriented testing, which is also an important question. Now, how do you do it? You use a conventional testing methodology altogether. That's a process which will use a waterfall life cycle, which is used in a developing. The testing is always performed during the test phase of the software development, which will usually follow after the development phase. Now, you keep proceeding phase by phase. Let's say first the piloting, then the coding, then again, you start getting into the development of it, then you start getting into a testing of it. Then we will do 3 kinds of testing. First, the system testing is going to be performed. Then the integration testing, we will do it. And finally, the unit testing we will do with the algorithm check so that everything is in phase. So whenever you see a waterfall model like this, it goes step by step here and finally it gets integrated to see whether it's as per the convention. Now, the object-oriented testing process is that where you would see that software is being treated like the object-oriented, where we use methods like encapsulation, inheritance, polymorphism, what you would have studied in your typical basic computer science classes. And here we start from the level of unit testing, go to the subsystem and then to the system-based testing. And in a higher order of testing, you will also see that the entire system is brought into picture, combined, integrated and tested. This testing method is a data-centric testing, and rather than algorithmic, where we don't just go with the algorithm altogether, we are more about a data-centric. So what happens in object-oriented is that every time when you're going to test something, you are going to see whether you are getting the data response correctly. Then only you will pass on to the next stage altogether. The next one is explain system testing for currency conversion program, which we are seeing. It's basically where you would see that first thing is that you will display the name of all the currencies that are going to be equivalent. Allow the user to select the currency from the menu, convert it to the other currency menu as far as possible. Then the user will have the option of displaying the screen or file. The screen will show the last 10 currencies that have been taken. Allow the exchange rate to be read from a file and the assumptions. Not all the countries are there. For example, there might be certain times where I assume that certain currencies are not available. There are code words, or sometimes the program will assume that currency input is in terms of integer, not in terms of decimal factors. Followed by the output results are placed into an array, where what we'll see that the maximum size of the array will be set at the time. The output array will be in a circular buffer that holds the last 10 conversions in your mind. Then formally going there, the currency will be based on the ASCII format. Then the file will contain one line for the each currency. Each line will contain currency name of that particular dollars in hand. So the program need will be only for up to 20 currencies in the file. When reading the currencies from the file, the menu of the each currency is assigned automatically. Program will have a Win32 console application, which will also be running from the command line as far as possible. Now, the design is that you have to be designing the number of countries, then the exchange rate, name of the country, and the position of the country. This is how the program would be designed. And next, what we would is that we would also go into the object-oriented system testing, which we have talked about. This is one thing very, very particular. Why? Because we are again talking about this encapsulation, polymorphism, inheritance, all those factors. And always keep in mind, whenever we are talking about object oriented, you have to start from unit testing, and then it starts getting into subsystems and the acceptance testing level altogether. With that, I come to the end of this particular session. I hope and believe that all the questions that have been discussed here will be of a great use for you in the final examinations. I wish all my students the very best for the examination. Do well. Take time in terms of reading the question and answer it clearly with an example. That will help you to score the best marks in the exam. Thank you once again for joining me today on this wonderful session.